Hi, everyone. Here we go with Chapter 9. So, if you would go to the lecture document, read along with me for a little while. So, we've definitely got some theory to work through before we get to our first practice problem. Chapter 9, as you can see, is hypothesis testing with one sample. So, it turns out we will study hypothesis testing in chapters 9, 10, and 11. It's a huge concept in statistics. This goes along with the theme of inferential statistics that we started in chapter 8. And there's definitely a lot of things that we did with confidence intervals in chapter 8 that are going to carry over to this idea of hypothesis testing. So a really, really exciting concept here. What is it? Okay, let me just start at the top there. It says every day we hear claims made about particular populations. Usually, these claims are meant to influence our thinking and decision making. So, a couple of examples here. A company recruiter claims their first year salary is more than the national average. So, what's happening? So, maybe you're about to graduate college or you're going into the workforce, getting that first big career position, and you're talking to different companies, and somebody at one company says, hey, we pay more than our competitor companies, right? Well, they're trying to get you to work for them. Maybe a tutoring service advertises that 9 out of 10 clients get at least a B. So they're trying to win you over to their services, right? Or maybe a commercial breakfast cereal boasts that it reduces the risk of heart disease. Each of these may be considered as a hypothesis, an untested claim about a population. So the idea is, as far as the person who's hearing any of these statements, this isn't tested, right? So someone's telling us this, but we don't know what it's based on. So we consider it to be like a theory, like a hypothesis is the technical name for it. It has not been tested, at least not by us. So to know whether what they're saying carries any real weight or not, we perform a hypothesis test. That is the procedure for testing the claim. Okay, so this idea of the hypothesis test, it's not something we can just dive right into. We're going to ease into this slowly. So I'm going to show you an example of, a full problem with some numbers of, an example that we'll see in homework and in the class. There's going to be a claim, and we're kind of invited to investigate that. So here we go with the full-blown example. A manager at Carl's Jr. wishes to know if the average salary of managers in the company is more than the national average of all fast food managers. Seems like that's pretty plausible, right? So someone's a manager at Carl's Jr. Maybe they're thinking of switching companies. And so they're going to ask the question, does Carl's Jr. pay more than other fast food companies? Because if they pay more, then maybe I'll stick it out with Carl's Jr., right? So then it says the national average, and that's talking about all fast food restaurant managers. The national average is $42,000 per year, but a random sample of 30 Carl's Jr. managers has a mean of 43,260 per year. Okay, so if you look closer there, we look at all fast food restaurant managers across the country. They're averaging 42,000, but we got this sample of only Carl's Jr. managers, and their average is 43,260. So that average definitely a little bit better than the national average. And so we're kind of wondering, like, I wonder if Carl's Jr. does really pay a little bit better. Now, at this point, I like to put it out there to the class and just see where people's intuition is. Just based on those numbers that you see, does it seem like, yeah, you know what? I think Carl's Jr. managers, on average at least, do make more than the national average for all fast food restaurants? Or do you think, yeah, I mean, I see that sample, but I'm really not convinced just based on those numbers? So I like to ask the whole class, and usually a few people respond, and usually there's kind of some debate. Like some people seem like that's enough evidence, other people maybe not so convinced. So if we kind of look what's going on, you know, just look at maybe like the sample size, right? So they asked 30 Carl's Jr. managers. And we consider kind of the cutoff for a minimum sample size to be 30, right? In order to be powerful enough to really be convincing. And they did. They met that cutoff. They got 30. I mean, that's a lot of managers, right? So that's a lot of salaries you're looking at. And the average of those 30 was 43,260, right, per year. So it certainly that's some evidence that, yeah, Carl's Jr. managers, maybe they do make a little bit more. Now it's not a lot more, but over $1,000 more per year, and a good sample size. So some people kind of argue that way. Yeah, I think this is enough evidence that, yeah, Carl's Jr. pays more. But then other people typically come in and say, well, it's true that they took the 30, but their average just, it wasn't that much higher than the national average. A little over $1,000, sure, but maybe it just that this particular group of 30, although it was done randomly, maybe still that group of 30 just happened to live in areas where people get paid a little bit more in general. And so maybe if we did another random sample of 30 Carl's Jr. managers, the results would be different. Maybe it'd be closer to 42,000. Who knows? Maybe even less. It's not clear, and some people argue that way, that they're sure it's some evidence maybe, but not conclusive enough. Okay, and so that's kind of the nature of everything we look at. We need a test. We need a way to investigate this. Here's what we're really trying to get at, that statement next. Is this enough evidence? Those figures that we see, is that enough evidence that managers from Carl's Jr. really do average more than $42,000 per year? How can we decide if this sample is typical enough? And so, we obviously will have a step-by-step test for how to do this. Here's kind of the logic, and we'll come back to this in just about every problem that we do. These hypothesis tests, they really have a similar feel to a courtroom and, say, a defendant who is on trial. So think of this claim that Carl's Jr. managers make more than the national average. That's like on trial. Okay. Do they really make more or not? And you may know that in the U.S., or in our court system, the defendant is always innocent until proven guilty. And so he'll have his lawyers, and the prosecution has their lawyers, and they're presenting evidence for both sides. But the prosecution really has their work cut out for them, because we always assume that the defendant is innocent. We need enough evidence to convict them, to err on the side that, no, I really think that this person did it. So that, is there enough, not just some evidence, is there enough evidence that Carl's Jr. managers make more than the 42,000, the national average? And so kind of think of, that question, that statement is on trial. But we kind of, and this will come back later, right? So we assume innocence. We're looking for enough evidence that it's guilty. So we're going to assume that Carl's Jr. managers actually don't make more than $42,000 per year. We're looking for is there enough evidence that in fact they very likely do? make more than $42,000 per year, right? And we're kind of getting at that second point. Is this sample typical enough? So if we were to do another sample of 30, which we're not, but if we were to do that again, would the results come back, in a similar way to what we saw in the first? So that's kind of like another angle to look at it. Could we be convinced that if we did more samples, we would get the same or very similar results to what we just saw? Is there enough evidence for that? Okay, so we're gonna build into this very slowly. We're gonna look at the null and alternative hypotheses. This is the foundation of the hypothesis test, and kind of how we set up, that this statement is on trial, and we'll have these two opposing statements, and we're going to see like how this, idea of this like innocent until proven guilty, figures in. Okay, the null and alternative hypotheses. The hypothesis test, okay, will always be between two possibilities called the null hypothesis and the alternative hypothesis. Okay, so what's going on here? So the null hypothesis, this is the position that there is no significant difference between a specific value and the larger population parameter. All right, so obviously this will make more sense once we do a practice problem or two, which is coming up in a second. But if I can explain just the name of this test, the null hypothesis, and null comes from the same root word as nothing, right, or like zero. So this is the position that there's no significant difference. And what we're looking at is actually not any different from the larger population. Okay. This is denoted as capital H sub 0. Again, null like nothing or zero. So capital H sub 0, the null hypothesis. On the other side is the alternative hypothesis. This is the position that there is a significant difference. Okay, and we denote that with capital H sub 1. And there's even a reason why we give them these names, null and alternative. Let's get into the first practice problem there, and we'll see it all fleshed out. State the null and alternative hypotheses. So we're easing into this, this idea of the hypothesis test very slowly. We're just going to state what would be the null and alternative hypotheses. And you see part A, it's our Carl's Jr. example again. And by the way, I'm not a big fast food guy, but if I do get fast food, I consider Carl's Jr. to be a little bit further up on the hierarchy myself. I like Jack in the Box as well. Okay, anyway, let's reread that one. It's going to be the same statement we saw a moment ago. A manager at Carl's Jr. wishes to know if the average salary of managers in the company is more than the national average of all fast food restaurant managers. The national average is $42,000 per year, but a random sample of 30 Carl's Jr. managers has a mean of $43,260. Okay, how are we going to set these up? So we're going to begin with the null hypothesis. Always start with the null hypothesis first. Now again, remember the null hypothesis, that's the nothing hypothesis. There's no significant difference. So what would that mean here? Let me show you. Here we go on finally to my camera. Part A, H0, the null hypothesis. So notice kind of the notation. We put H0 and then a colon to say the null hypothesis is that the average Carl's Jr. manager salary is equal to $42,000. You might even say per year. So we're assuming that we're going to start with the null hypothesis. We're going to start with Carl's Jr. pays the same as everybody else. There's no significant difference. Those managers, they make the same as all other fast food restaurants. Okay. Then the alternative is based on what we're investigating, right, in the problem. So it said this person is wondering if Carl's Jr. actually pays more than the national average. And so that's what we state for the alternative. So you see we write H, capital H sub 1, colon, and we're going to say now the average Carl's Jr. manager salary is more than $42,000 per year. Notice in the alternative hypothesis, we still use 42,000. We're just saying it's not equal to 42,000, it's more than 42,000. So you may be wondering, hey, when does the fact that the sample of Carl's Jr. managers, the fact that they had an average of 43,260, when does that come in? It will come in, but later on in the testing. So turns out this null and alternative hypothesis is step 1 to the hypothesis test. So it doesn't come in here. The actual sample average, that would come in later on in the test. That's kind of like where we're testing to see if there's enough evidence. But here in the null and alternative hypotheses, we say, okay, the null, there's no significant change. Carl's Jr.'s, they make the same as everybody else. Alternative is what's kind of in question, what's on trial, if you will. Do they actually make more? Okay. Now, just to sort of connect the dots in how the test would play out and kind of this idea of innocent until proven guilty, we always assume the null hypothesis. We're looking, is there enough evidence that actually the alternative hypothesis is the true one? So we assume the null hypothesis is true, right? We're going to be highly skeptical. It's kind of the way we do this, where it's not a 50-50 chance between these two. We err on this and we're saying, I'm going to stick with this unless you give me plenty of evidence that I need to switch to this. So we assume the null, we assume there's no change. You got to really convince me that it's the alternative, and hence why it's called the alternative. Right, same idea like in a trial. We assume they're innocent. You really got to show a lot of evidence that they are guilty in order for us to jump to the other one. Okay, so the way I've presented number 1A here, this is certainly fine. However, there is a more mathematical sort of notation that we can use to write these things a lot simpler. So I think it's good that we see these here written out in words. Kind of helps us again to ease in. But there's a faster way to do this. So we say or, and I'll just show you both of these. So this will save you a little bit of writing, and it will even help with the later steps in the hypothesis test that we'll see in a bit. Instead of writing it out in words, you can do this. H0, the null hypothesis, colon, mu equals 42,000. So what is that? So that's the average, right? Mu. And we're going to say the average Carl's Jr. manager is equal to 42,000. So mu equals 42,000. Where the alternative, H1, well, that's when the Carl's Jr. manager, when they average more than 42,000. So we'll say mu greater than 42,000. So I highly recommend write it in this style. That's the way I'm going to be doing it for all of these. Certainly nothing wrong with writing it out in words, but this is even going to be helpful for the formulas and things that we see a little bit later. Okay. Let's move on to part B. Here's a new example. This will be good. A psychologist feels that playing soft music for students during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower if they play the music. Over the past several semesters, the mean test score has been 73. Okay. So the psychologist feels like, maybe if I play soft music, that's probably going to change the results of the test. But will it, kind of relax people and they'll score better? Or maybe it will be a distraction and they'll do worse if we play music, right? So we're not sure. All we know is that we think it's going to change the results somehow. And we know that over the past several semesters that the average has been 73. Okay. So for part B, again, I'll write it out in words and then show it to you in the more compact form. So here, the null hypothesis is that there would be no change. So we're going to assume that there's no change at all if they play music. So H0 colon, the test average with music will be equal to 73. Playing the music's not going to change anything, is the null hypothesis. What's the alternative? And now here we want to be careful, and there's a reason I'm giving you two problems. The alternative, and with the alternative, you got to be really careful about how the problem is stated. So H1, the test average with music will not equal 73. Okay, what's up with this? Why do we say not equal here? Because it says the psychologist is not sure whether the grades will be higher or lower. We don't know if the average will be over 73 or under 73, greater than or less than. We don't know that. We just think it won't be 73, whatever it is. Okay, that is different than the previous problem, right? So in the Carl's Jr. example, what was in question was, do Carl's Jr. managers make more than 42,000? That's what was in question. We're not even considering that Carl's Jr. might make less. All we're worried about is, do they make more than the average? Here, that's just not the situation. And it's all based on the way the question is presented to us. The psychologist isn't sure whether grades will be higher or lower. So whatever it is, it's just not 73. Okay. Now, we could also put it in the more compact form, and we really prefer this, honestly. H0, that the mean, when they play music, the mean will still be 73. Or the alternative, that mu will not equal 73. And again, notice we're writing a not equals in this problem as compared to a greater than in part A, and certainly other examples that we will read later might have even a less than symbol, right? Just based on the way it's presented. Again, when we actually do the test, we always assume the null hypothesis. We're going to assume music doesn't affect anything, and you need to give us a lot of evidence that, in fact, it will change the test score. Right? Innocent until proven guilty. Okay, and then we got that last statement down at the bottom of page 1. The null hypothesis is always assumed to be true. It takes very convincing evidence for the alternative hypothesis to win, and that's what we've been saying. Right? Innocent until proven guilty. Okay, let's stop this video here.